These followed me home from a recent ham fest. They were in a box, and really good ham fest. Anyway, from right to left, here's a 432B power meter, a HP. These are nice. I believe these have Nixie 2 readouts in them. This is kind of a more rare run. This is the one you find more often. Here's a 432A. I did another video on a similar item here that that I had. Also in the lot was 431C power meter, and this one, which assuming needs a little work, a 431C power meter. This one looks like it's going to be a donor. I asked the guy, did any of this stuff work? He says, I have no idea. So that probably tells you the condition. But the main reason this attracted me was in the box, along with these, was two of these thermistor mounts, the HP 478As. These go from 10 megahertz to 10 gigahertz. And there's two of them with the cables. And it even had the extender cable for it. So that's the main reason I really went with this. Very reasonable too. It didn't cost very much. These things are very rare and expensive. And if they're good things to have. I'm going to measure the resistance on these and see how they fare, and then I'll try them in my other unit. I'm especially interested in this one. I like the Nixie 2 readouts on these things, so I think I'm going to take a look at this one first and see if we can get this one running here. There's calibration data on some of these, which really isn't any good anymore. I think one of these has a calibration sticker. I can't remember which one. Control number, yeah. Came out of some industry, I don't know where. Anyway, I'm going to start with the 432B power meter. Let's see if we can get this thing running. Anyway, stand by for that. First test of the 432B. We got it plugged in, and we have nothing. We have 0 amps. And of course, no power. So, obviously we got a problem. And obviously the calibration, I should say the warranty sticker's been opened. Well, it doesn't smell bad. The inside looks fairly clean. I'll have to let's check the fuse. Boy, there we go. Is that any good? Let's check the fuse. It's not the fuse. So we've got another problem. Anyway, I guess it's time to dig in. I'll check the power supplies first, and then we'll go from there. Stand by. Here's a manual supplement for the 432B power meter. According to this general description, the Hewlett Packard 432B power meter is a digital readout version of the HP 432A. So obviously they just put a digital panel meter in it here. The only electrical and mechanical differences between the two are changes that were made to accommodate the digital panel meter assembly. And looking here, looks like they outsourced an analogic from Wakefield, Massachusetts model. You can read it here. Anyway, that's the digital readout here. And it is Nixie tube, which is interesting. Something I noticed, if you look down here, there's a burnt resistor. It looks like it runs from the fuse holder to the power connector here. And looking on the schematic, here, there's two 10 ohm resistors here. As the power comes in, it goes through two 10 ohm resistors. So I'm measuring no voltage on the on this side here. So obviously we've got a burnt resistor here. So I'm going to check that next. And they're before the fuse here, which is interesting. So you've got two cap filters to ground, and then you've got these two 10 ohm resistors. So the fuse checked good, so that makes sense. So I'm going to check those two resistors here. That may be where our problem lies in this thing. And there you can see R7 right there next to the fuse. And there is its resistance. That looks like about a, what, about a 2 watt resistor maybe. I'll have to check the parts list here and see what size that is, but it's a 10 ohm resistor. Well, that shows R6 and 7 film resistor, 10 ohms, 1%, 1/2 watt. Boy, that looks like a big 1/2 watt resistor to me, but that's what they call for. I put a bigger one in there, but I'm sure that's why they did that, sacrifice a resistor. Although there is a fuse, there's a fuse in series with this, so oh boy, I might go with a little bigger. I might go with a 1 watt. Might as well. Here's the original 10 ohm 1/2 watt, and here's the new 1 watt 10 ohm Chinese equivalent with genuine steel leads. Why they're using steel leads, I don't know. Well, actually I do know. Anyway, what are you going to do? It's measuring 10.8 ohms. I almost hate to put that in here. Maybe I'll go down. Well, I'll put it in there and see what happens. I do have some better new old stock down in the building, one of the buildings there, but I hope Bill and Dave aren't upset, you know, as in Hewlett and Packard. I guess they won't be complaining. Anyway, I'll put this one in and we'll see what happens. If it goes up in smoke, we'll continue investigating. Stand by for that. A new 10 ohm, this time 1 watt resistor. I replaced R7. R6 measured good, just a hair over 10 ohms. So I'm going to give it a try here and we'll see. Ooh, don't like that. Anyway, we'll give it a try here and see what we get. Hopefully that is what the problem was. Stand by. Time to give it the, hopefully not the smoke test. Anyway, here's power. And the nixies are glowing, which is good. So far the resistor is not glowing, which is good right here. Interesting. Maybe it just died of old age. Anyway, I'm going to connect, I'll put it back together here. I'm going to let it run for a while. Make sure that resistor doesn't open. Keep my eye on that thing here. Anyway, I'll put it back together partially, and then we'll hook a thermistor mount up and see if we get any measurement. Hopefully that's where the problem was. So stand by for the next step. Okay, I set this up the same as the other power meter I did in one of my last videos. I've got 30 dB of attenuation here, 20 and 10, and I have a HTX 404 UHF handy talkie on 440.5. The power meter is on 10 milliwatts. So let's key it and see what happens. 1.7 milliwatts. Well, we're getting something here. I'll key it again. 1.7. So obviously the thermistor mount is good on this one here, so that's good. I think what I'll do now, I'll connect the same setup, same system up to the micro watt, the Boonton, and we'll see what kind of reading we get with that. So stand by for that. The transceiver is connected up through the 30 dB attenuators into the Boonton here, and I got it on the 1 milliwatt scale, so I'll key the transmitter, and we're getting about 850 milliwatts, something like that, looks like, on the 1 milliwatt scale. So there's a little discrepancy between the 432 and the Boonton here. Could just be calibration. Anyway, at least we know the thermistor is measuring. I'm going to try the other thermistor mount on this unit, and we'll see if we get a similar result. Okay, I need to go through the zero out the meter here as close as I can. Well, that's close enough for now. Let's go to 10 milliwatts, and I'll key the transmitter, and I got 1.4 milliwatts. So apparently I swapped out, this is the second thermistor mount. This is the initial one that I think I read 1.7 milliwatts going through this assembly. I'll key it again. 1.4. I should probably run this off of I'm running it off the battery. I should probably run it off of a regular supply here. Let's see if the battery light comes on when I key it. No, not yet anyway. Anyway, I think with some calibration this is going to work. So, turned out a good deal. I've been looking for thermistor mounts for many years. You never found them, and now within the last 2 Hamfest I've got 3 of them, so figure that out. So this repair took all it took was a 10 ohm resistor that had opened, and we're back in business. So eventually we're going to have to get some type of standard we can calibrate all our instruments. I'll get one calibrated, and then I'll calibrate the rest of them to that standard. So let's go back to, yeah, see, this is, I should probably let this warm up a while before I there. Try it again. Oh, now we're 1.7. Okay, that's the same as the other thermistor mount. I reset the calibration here. You have to go through the coarse 0 and the fine 0. And when I did that, now I'm getting 1.7. That's the same thing as the other one here. So maybe my Boonton's off a little bit. So anyway, that's encouraging. Just for fun, I've connected the Radio Shack HTX 404 up to this Leader LPM 880S power meter. This has a built-in dummy load, and you can measure up to 120 watts. It covers VHF and UHF. Well, anyway, on the 432B, I measured about 1.7 milliwatts, and with a 30 dB of attenuation, that would be 1.7 watts coming out of the radio. So now I'm going to turn this on, and I'm going to key the transmitter. I've got it on the 5-watt scale, and I'm measuring just under 1.5 watts. 1.5, yeah, just about 1.5 watts. So that corresponds with what I'm getting on the power meter here. So I'm thinking the Boonton might be measuring just a little bit low. So that thing hasn't been calibrated forever, so that might be what we need to do. Anyway, I thought it would be interesting to look at directly into a watt meter Anyway, I think I'll finish this one. This will be a short video. This is repaired. I'll put it back together, and maybe we'll do a calibration when we get a source of an accurate source to calibrate these things. Anyway, I hope you enjoyed it. These seem to be really rare with the Nixie tubes here. Anyway, thanks for watching this one, and we'll see you in the next one. Bye for now.